or specific resistance. So we have R equal to resistivity L upon A. So if I make rho on one side, I'll get R A by L. Now we have seen that R is measured in ohms and A is measured in meter square because that is area and this is meter. So the SI unit of resistivity is ohm meter. Okay, so this is the SI unit. Now, how do you write a definition for resistivity? So if you take the area as one square unit, and if you take the length as 1 unit length, then what do you get? Resistivity numerically equal to R. Resistivity is numerically equal to R. So that is the definition of resistivity. So resistivity is defined as resistance of a wire of a material of unit length and unit area of cross section. So this definition is also important to know. Also, what you need to know that resistivity, of course, depends on the material. That means if it is a good conductor, if it is a metal, it has a lower value of resistivity. And if it is a semiconductor insulator, it has a very high value of resistivity. Okay, another thing that affects resistivity is temperature. So if the temperature of a material increases, we have seen that resistance also increases, so does the resistivity. Okay, now another point to remember. So for example, silver has resistivity 1.63 into 10 to the power minus 8 ohm meter, okay, at 20 degrees Celsius. So the question that will be asked is, what is the meaning of that? Okay, what is the meaning of this? So the answer to that is, if you take silver of 1 square unit and length of 1 unit, then the resistance offered by silver will be 1.63 into 10 to the power minus 8 ohm. So that is how you write the answer. So that is also an important question to expect. Okay. What else? To give you a slight idea. So silver I have written. I'll take an example of a very, like whenever you talk about semiconductor, you talk about silicon. So silicon has a resistivity of 2.3 into 10 to the power minus 5 ohm meter. So you can see that silicon has a resistance like almost 1,000 times of that of a metal. Whereas an insulator, okay, we'll take an example of an insulator like glass. Now glass has a resistivity of the order of 10 to the power 10 to 10 to the power 14. So imagine 10 to the power minus 8 to 10 to the power 14. So that means it is 10 to the power 22 times resistivity is more. That's very high. So obviously, when you have a glass and you have a metal, it is impossible to conduct electricity, okay, through glass. It is because of such high value of resistance that it offers. Okay. Again, you don't need to know the values. You just have to understand that, how is the difference between the resistivity of these materials. So conductivity is denoted by a letter sigma. This is sigma. Okay, and conductivity, as the name suggests, it will be reciprocal of resistivity. So therefore, the unit will be per ohm per meter, or it is also called as Siemens meter. SIEMEN, Siemens per meter. Okay, so for example, power transmission wires, so or wires for electrical connections. So name means you will have names like copper, you have aluminum. So these are the materials. And why? Because they offer negligible resistance and the resistance remains unaffected by heating. Okay, a small amount of heating will not affect their resistance. In resistance wire, you have a material like manganese, constantan, and what is the reason? Their specific resistance is high, and the effect of change in temperature on their resistance is negligible. So let me take you back to that table. In the table, you have silver has 10 to the power minus 8, and it is 1.63. But if you take an example of something like constantan and manganese, it is like 44 into 10 to the power minus 8. Silver is 1.63. So even if you take it as 2, so this is like manganese has 22 times the resistance. Constantin also has 25 times the resistance. So that is why they are made into resistance wire. So remember, it's not a huge thing, but that is what makes the difference. The resistance offered by, say, a silver wire, and if you take a Constantin or manganese wire of the same thickness and same length, it will offer around 22 to 25 times more resistance than what is offered by the metal conductors. Okay, so that is resistance. Then you have fuse wire. Fuse wire has the name is alloy of lead and tin, and the reason is it has high resistivity and low melting point. You have studied that in the chapter household electricity, that because of high resistivity, it does get heated up, and because of low melting point, it melts, and thus it breaks the circuit and prevents the appliance from getting damaged. Filament of bulb is tungsten. Tungsten has a high melting point. Okay, so and that is the reason why it does get heated, but it will not melt, and it gets so hot that it starts glowing. Then you have heater element, heater, toaster. Okay, so the wire that is used over here is nichrome, and nichrome is having resistance like 50 times that of the metal, whereas we saw in resistance wire, Constantin manganese had around 20 to 25 times, but for nichrome it has 100 times. So therefore, nichrome wires are used in geysers, toasters, microwaves. So in superconductor also, you need to know the definition, and you need to know examples with the temperature. So as the name suggests, superconductors offer zero resistance at very low temperature. Okay, so zero resistance can also be written as infinite conductance. And the example is mercury below 4.2 Kelvin, neodymium below 4.9.2 Kelvin, and so on. So you need to know the examples along with the temperature.